Okay, hello everyone. So so today we'll just be going over introduction to 3D printing, and I'll be taking you through some applications in some industries. So I don't think we'll be able to cover all the industries, but we'll try and get through as many as we can. So just to introduce myself again, my name is Akinwola Akinpelu, and I founded Stampar 3D back in 2015. Um, so back then, so that was when 3D printing was just gaining prominence, and I checked if there was anyone doing 3D printing here in Nigeria, and it just was unheard of. So that kind of led me to start Stampa 3D. So Stampa 3D literally means 3D printing in Italian. I think back then I was, for some reason, fascinated with Italian, Italian and Italian people. So over the years, we've had plenty notable clients. Um, the likes of Chevron, LLAN, which is a construction company, and Sava Homes, which is a furniture company here in Lagos. Okay, so I guess we could dive in. So what is 3D printing, you may ask? So 3D printing is an additive manufacturing process. Now, during the course of this presentation, I'm going to be interchanging the two terms of 3D printing and additive manufacturing. They literally mean the same thing. So, 3D printing is an additive manufacturing process which makes object layer by layer. Now, a it is a manufacturing process on its own. Before 3D printing, so I would say way before it became really popular, we had our three main manufacturing processes. We had forming, which a lot of people know as molding. I mean, so molding is a kind of forming manufacturing process. You can think of it as our injection molding. We had joining, which you can think of as welding, and we have subtractive manufacturing, which you can think of as, I guess, your CNC milling, and even like your carpenters. So when your carpenters make furniture or whatever it is they're making, that manufacturing process is subtractive. So additive manufacturing has come to become a fourth manufacturing method. Now, I would like you all to think of it as an addition and not a manufacturing technique to compete or to replace any of the previous manufacturing methods. It is a manufacturing method in its own right. And since then, it has seen steady growth. So since it started gaining prominence back in about 2010, it's seen steady growth over the years and actually surpassing what has been forecasted. Right now, about 2020 or in 2021, I think the market size is rapidly approaching the 30 billion mark. So I guess we can safely say that additive manufacturing is here to stay. Is more than just a, a farce. Now, what is additive manufacturing? So what's the technical definition? So what is 3D printing? So 3D printing is an additive manufacturing process in which a physical object, so that's the end goal, a physical object is created layer by layer from a computer 3D model. So you must always start from a computer 3D model, and then you form it layer by layer until you get your physical object. So let's just talk through the workflow. So as mentioned, you need to start from a 3D model. Now, how do you get your 3D model? You can get it in three ways. You can either go online and download it. So you can, if you're looking for, let's say, a phone case, you could just go on Google and type in um, iPhone 11 phone case 3D model, and you will find a 3D model of an iPhone case. So that's one way of getting a 3D model. You could also scan the physical object. So if you have a physical object, we have 3D scanners in the market now. And actually, I think some of the newer phones actually have 3D scanners inbuilt into them. So you can scan an object and get a 3D model from that scan. So that is a second way of getting your 3D model. And a third way is just designing one from scratch. So you can use any of the 3D modeling applications out there. I think there's quite a lot of them, like your Autodesk Inventor, your Rhino 3D. It doesn't really matter which one you use. You can use anyone that allows you to build a 3D model. Now, once you have the 3D model, you go through the next stage, which is called slicing. And that is a process whereby you turn your 3D model into a language that the 3D printer will recognize. Now, typically, when you get a 3D printer, it will come with its own slicer. Um, and being digital manufacturing, I mean, this is digital manufacturing. The slicer allows you to control every aspect of the resulting part. So the part that you 3D print allows you to control every aspect. So now, if we look at this, if we look at the images I have here on the right, my 3D model was the same for all these images, which was a cube, an open-ended cube. So in the top row, you can see it going from 0% to 100%. Now, this slicer, the slicing software allows me to modify the internal structure of the 3D model that I feed into it. So I can either make it completely hollow, which is 0%, or make it completely solid, which is 100%. I can change the internal structures, and the wall thicknesses. I can also change, modify the wall thicknesses. So that's the beauty of additive manufacturing. It allows you to, it gives you total control of every aspect of your production. So now, I guess we could take some brief questions. I think following
Yeah.
this, we'll dive into application. So Victoria, I think you're gonna.
Yes. Yes. Thank you very much, Akin, for that. I hope it's fine if I call you Akin. Um, just before we take questions, in the meantime, you can leave your questions in the chat box. It's very interesting what you said about the slicer and how making the slicer different, giving the slicer different configurations could actually affect the printing. I remember, I think last week or thereabout, I remember attending a presentation from the Institute of Advanced Studies. It's an architectural school in Catalonia. And I think one of the things that was talked about was how they are using um, that slicer configuration to really work with buildings. So some of the images I have here, for example, um, this is this is a building from Maria Fuchinella Architect. I don't know if I pronounced that correctly. I apologize if I ruined the name. But basically, this is an a sustainable settlement that they are already building. And the unique thing about this project is that they're using more than one 3D printer at a time, which is not very common for most buildings that have actually been done. So if you look over to the left, you can see a collection of 3D printers. And interestingly, they had to actually make sure that the 3D printers can work in such a way that they're not colliding with each other. Um, they also sort of look into how they can re-engineer the the walls of a structure using those slicer settings so that it can become even more resilient than your regular building. So, like this one, for example, they've used the structure of the slicer to create a staircase that is embedded in the wall. So there's no need for an additional structural element. They're also looking at how you can combine self-supporting materials like clay and then just use timber to support them. They're also looking at structures that are self-supporting, like the arch, which in block work or brickwork, we already know that arch kind of supports itself. So now that you're using 3D printed material, how can you re-engineer that to more resilient and so on. And I think this project, person was looking at how you can use those slicer pathways to create your own kind of insulation that is inbuilt into the structure. So I think it's very interesting. But maybe perhaps you could tell us more about you could tell us about some other industry applications, because this is what I've just learned from my own personal research. So maybe you could enlighten us while we're waiting for questions from uh, the attendees, like some of the industry applications you've done for some other industries and so on. Yes, before you
Yeah.
start, someone is asking, can you tell us about how to get smooth effects in 3D printing? And I believe that has something to do with the what do they call it now? The contours that are a side effect of like fuse deposition over time.
The Okay, so actually, can you repeat that question?
So can you explain how you can get a smooth effect in 3D printing? I think one of the things you show us now should address that. So maybe just go ahead.
Oh,
Basically,
okay.
yeah.
Okay. So I think what the question is all about is how do you get surface a smooth surface finish?
Yes.
Um, okay. So like we said in the beginning, additive manufacturing is a layer by layer process. So the layering effect, we cannot really get rid of that because that is how the object is built. It's built in layers. Now, what we can do is with our slicer settings, we can modify the thickness of this layer. So the thinner the layer is, the smoother your resulting object will be. So we can actually modify this setting. But another way of getting rid of these layers is by post-processing. So once the print is done, we can then maybe sand the product through to make it smooth, or add like some form of coating just to smoothen those layer lines, depending on your application. So some applications will allow you to do that very easily, some maybe not. And some the layer lines may be like a design aesthetic. So it really does depend. So now talking about applications of 3D printing, I would like to break them down into three main categories. So all these industries, they all use additive manufacturing in one of these three ways. So the first way is for rapid prototyping, which um, pretty much involves creating a representation of what your final product will be. So in cases where your final product needs to be manufactured maybe through forming or injection molding, the initial prototype can be made from using additive manufacturing. The second main category is rapid tooling. So this is where you use additive manufacturing to make a tool that would allow you to get to the final product. And the third way, rapid manufacturing, which means you're directly manufacturing the final product using additive manufacturing. Okay, so now we've already kind of talked about this. I think Victoria touched on it, but I'm just gonna kind of rehash what she says. So for architects now, how do architects use it, or how can architects use additive manufacturing? So first of all is, they can make site models. So either making a standalone model of a building, or creating like a whole site build. So if it's a standalone model, um, that can be one of two ways. It could be closed or open. So closed is you are only interested in the facade, and your 3D model will have to be a solid block model. The other way, if it's open, then you want to show your client the internal structures of the building. Now, how you get to this 3D model is actually very it there's a process to it, and I think that there's going to be a course that addresses that, how you can go from, say, your full Revit model to a 3D printable 3D model. whether it's closed or open. Then the other is building a whole site. So you're trying to build the resulting landscape, have like your streets and your cars and your street lights and maybe even building lights. Now, how to go about this? It really does depend. You have to break down your building into the smallest possible component. So the example I've shown here, so this particular site that we built, we had to break down the different portions of the building. Not everything here that you see on this picture on the right was 3D printed. Just certain parts of the building was 3D printed. Other parts we used commercially available trees and grass and the cars as well. That is commercially available in any hobby store. We also use the cardboard, laser cut acrylic, and then just assembled everything together to form the building. The bits that were 3D printed are actually the bits in gray. So everything in gray was 3D printed. Everything in white was simply just laser cut, and especially things like the columns and the pillars, that was either laser cut or made out of cardboard. So sometimes 3D printing may not be the ideal way of making the building, especially for site builds like this. Um, so another application in construction industry, we now have industrial 3D printers that actually the raw material is cement. So you have these big 3D printers mounted on cranes actually building houses. The use case for this is now you can build a house in as little as 24 hours. So once you have the design and you have your internal structures like Victoria mentioned, you can literally build a well-insulated house in as little as 24 hours. And during this COVID period, I know in China they were building isolation centers with 3D printed. So these are just very simple buildings that could give them extra bed space. Okay, now in the manufacturing industry or production industry, this is from an FMCG company, and they gave us this design. They gave us their specifications to produce a. I think they were selling. They wanted a new packaging for their detergent, like some liquid detergent. So they sent us the specs. So we, after a bit of back and forth, we developed the 3D model for it, and then we did a 3D print, which we will then send back to the client, and then they can do all sorts of testing for it. Maybe get feedback from their consumers to say, okay, do you like this shape? I mean, the consumers can actually feel the bottles and experience the whole economics of it. And once they have a set design, then they can now take the step to mass produce, which is another manufacturing method um, that is maybe a bit more capital intensive than additive manufacturing. So this just allowed them to develop a prototype before going into full production. Okay, so for engineering, now the two images I have on the left, there's a video that we'll watch later on, but the two images I have on the left was, so this gear was part of a car. The it was a gear within a motor that takes the glass up and down, for winding the glass up and down. And the original piece had the teeth of the gear had gone out. It was completely worn. So what we did in-house was we took out the worn out gear, we um, reverse engineered it, created a 3D model for it, and then 3D printed it again, inserted it back into the housing, and printed it and sorry, installed it, and everything worked fine. So now without additive manufacturing, it's going to be hard to actually make use of this motor again. In fact, the normal thing would be to actually condemn the motor because of something like this, because you can't go into the market to buy replacement gear, even though it's something as simple as a plastic gear. So there are lots of examples like that. But now let's just watch this video. In this case, this is for a submersible pump, which had worn out impellers. So I'm just going to play this and maybe talk through it as well. So this is the submersible pump, as you can see. Submersible pumps now go for about maybe 180 to 200,000 naira. Now here are the impellers. The impellers had completely worn out. Let me just take that back. Yeah, so the impellers were, they got fused together. They completely disintegrated. And again, the normal thing to do would be, oh, let's condemn this submersible pump and get a new one. But in this case, what we did was we took out the broken impellers, we reverse engineered it. So we took it into CAD. Once it had a 3D model, we 3D printed it, as you can see on screen now. And then we tested it. So after we assembled, we tested and installed it back on the pump. We tested it back on the submersible pump, and it works fine. So this is a situation where we just saved a piece of equipment from, being recycled into, God knows what they use these pumps for after their service life. But yeah, and that is just because it had broken impellers that can be replaced by 3D printed parts. Okay, now for the medical slash dentist industry, okay, I'll go through each of these images. Now, the first one, so of course, during this pandemic, I would say about this time last year when things were just kind of heating up. I'm sure we can all remember the global mask shortage, where you just couldn't get masks anywhere, and all these health centers and hospitals were struggling. So what we did was we got these designs for this particular mask, which is this image in red. Um, and so it's a plastic mask which can be reused over and over again. It can be disinfected, and it had reusable filters. So we started supplying this to the local hospitals and any hospitals that needed, actually, which allowed them to to carry on working and serving the public. The image in green, now this little boy is an amputee. Um, Now for this age, I mean, he is still growing, and he had his hand amputated. Now, a 3D printed arm was made for him, and this has no electronics or anything, but it's still a functional arm. So using like strings and joints, it allows him to control the fingers, so he can actually pick up and drop things just by flexing the muscles of his stump. So the amputated stump, by flexing the muscles, he's able to pick up and drop things. So this is quite a pretty good example of what additive manufacturing can do in terms of the final product. Now the image in orange, which is showing dentures. Now for our elderly people, especially people in the West, after a certain time, they're going to need dentures. Now, as you can imagine, everybody's dentition is different. Everybody's jaw shape is different. So being there's no point mass manufacturing dentures or anything. So this is where 3D printing comes in. And what all of these dentist how hospitals are doing is they will get a mold of the patient's jaw shape, convert that to a 3D model, and then use that to 3D print dentures for that particular patient. And so this will be like a perfect fit for the particular patient. Then the image in blue, so this was an example of rapid tooling where a hospital within UI, a surgical clinic within UI, wanted to do I think would have been a pretty complicated surgical procedure. I'm not sure, it could have been a brain surgery, or I, I don't really know these medical things, but so they needed to get the actual score of the patient and know how to, which will allow them to I guess make the surgical procedure a lot more effective. So they sent me this direct MRI scan of that particular patient, which was converted to a 3D model, and then we got that 3D printed, which is what you can see here. Sent it back to them, and then they were able to carry out their findings before commencing on the surgical operation. So this examples, these are just examples of how the medical industry uses additive manufacturing. Okay, so now for product design, so this is when you're trying to release a new product into the market. You're trying to bring in something new that doesn't exist. So initially, this project was funded by Lexus, and the goal was to develop a face mask. So in a world where COVID is here to stay, where um, everybody has to be walking around with masks, is it possible to have more fashionable um, masks that will protect you but still kind of look good? So that was the essence of the whole project. Now, so the first brief, the client gave us the brief, which were just sketches. And then from the sketch, we developed the 3D model for it. And from the 3D model, I mean, of course, there will always be lots of iterations and back and forth. But we developed the 3D model. From 3D model, we went to the 3D print. Here you can see the 3D print of the mask on a bust. So this bust was made out of clay, and that just allows us to, see how the mask would potentially look on the person. And then once that was done, we sent off so once we had good dimensions and a good fit, we sent that to a metallizer. I think you call them metallizers, who then converted the actual 3D print to a metal part, and then also did the visor in clear acrylic and all of that. And that's the final product you can see on the right there with the model lady. And now a good thing to highlight here. So this whole product development cycle took about 2 to 3 months, where previously, before additive manufacturing, you'd be looking at years, with the whole back and forth, and it would have taken years. But what additive manufacturing allows you to do is really condense that time down to either weeks or months. Okay, so with jewelry now, so this technique is done, is presently being done in Nigeria, where you can make very, very custom jewelry. How this is done is you will use our 3D printed, maybe using wax or something as a raw material. We'll use it to make a very precise version of the end product, which in this case is a ring of our chosen design. And then we create a mold around that, and then pour in our metal. So pour in molten silver or molten gold. And as the molten metal is going in, it's melting away the 3D print, the wax 3D print, and completely taking the space. And then what you're left with at the end is a solid silver jewelry that was initially designed on the computer. So this is currently being done by this company. That's the Instagram handle over there, if anyone is interested. So it's not just rings you can make. You can make brooches and pendants and all sorts using the same technique. Now in the fashion industry, so what are the fashion people doing? So here we have in blue here, the images in blue, quite interesting shoe design was done, and you just have to add straps to it. So you do your shoe design online, you 3D print it, add your straps, and then you have a nice pair of shoes. Now I can't say how comfortable this would be, but I mean it is possible. And because it's digital manufacturing, you can actually really go crazy with the design. It depends on how far out you can think of these things. And if you look at the design in purple, I mean this is a design that you can't manufacture using any other technique, you know. And because you are controlling every aspect of of the production, you can strengthen certain areas. So for this shoe here in the purple image, I can imagine the heel section will be extremely solid, would have a lot more strength, and then there will be some savings up top where not much strength is needed. So another use case is with this. So there's a company in Nigeria called Shekudo, and what they're doing is they're printing interchangeable heels that you can attach to, I guess, just about any type of shoe. So you attach the template to just a normal pair of shoes, and they can slide in and out different heels. So if you want like 4-inch heels today and 1-inch heels tomorrow, with the same pair of shoes, that's now possible. The images in yellow, now this just shows that you can 3D print using very flexible material. So in this case, just a pair of, I guess, slippers. I'm not sure what you call this type of shoes, but here you're using flexible material to print shoes directly, which you can wear. Now, of course, it's not just about shoes. If we look at the images in orange, what you have here is something called chain link or chainmail, where you 3D print using hard plastic, a almost like a chain type material that you can then form into any shape. So this can be formed into, say, a t-shirt or a belt, or a tie, and yeah, this is currently being done. It's Again, I don't know how comfortable this would be, or if it will ever become mainstream, but it just kind of showing what is possible and pushing the whole industry forward. Okay, now interior design. So this is probably I guess, maybe the most creative of everything, because I mean, it just there's literally no limit to what you can do. It depends on your imagination. So this first image in pink. Now in our workshop here, we needed an exhaust system that can exhaust from three fans into one outlet. So there's three fans coming in, and it's exhausting into one, from one outlet. And in the market, nothing like that existed. So we couldn't find a suitable 3-to-1 conduit. And so what did we do? We designed one, and we 3D printed it. And now we are currently using it in the workshop, just to exhaust some of the stale air and the fumes and everything from our machines. The one in orange is a bit more, it's not so serious. So this is a pet water feeder. And it's a very simple design, but still a very effective design. And what this does is it just ensures your pet, so it could be your cat or your dog or whatever, always has water. So you take a full bottle of water, you turn it upside down, and it will automatically fill up to a certain level and stop. So every time your pet drinks from it, the water tray is refilled. I mean, very simple design, but very effective. Now the image in brown. So this was from Sava Homes, actually. Now they were going for an exhibition, and they wanted a furniture design to showcase, one, 3D printing, but also some design thinking. Now the design they have here was meant to mimic the National Theatre. So the sensors, the designs, we 3D printed it. We had done all the strength analysis and everything. So we had strength in places where we needed it, and it was hollow in places that didn't really need to be strengthened. Maybe needed to be a bit more flexible. And here you can see we after printing we assembled it and placed the pane of glass on top. Now the glass that is being supported here probably weighs about 10 kg, about 10 kilograms, but it is being supported by all this legs. So this is a furniture example of 3D printing, a coffee table here in this case. Okay, so movie props. So within the movie industry, we also have 3D additive manufacturing being used extensively. I'm sure we've all seen Black Panther. Well, most of us have seen Black Panther. Now, the Queen Mother of Wakanda, her costume was almost entirely 3D printed. So the hat and the shoulder pads, so that was all actually 3D printed. In the black image, so this is a full face helmet of a Star Wars character, so another movie character, Darth Vader. So this too was entirely 3D printed. But you also have you can also 3D print things like weapons and all sorts. So the there's a big scope in the movie industry to 3D print props and things for their movies, for their production. And finally, we have education. So what I'm showing here is like 3 different levels of education. So the first set of images, the green image, so that's just 3D printed Montessori puzzle. So where for the top image, the map of Africa, so each country is a separate 3D print, which you now put together to form the continent. And in a similar fashion, it was done with the country Nigeria as well, where each state was a separate 3D print. And just to make it a little bit more interesting, it's been broken down by, so in the state of Nigeria, the geopolitical region is one color. For the map of Africa, the H part of Africa is one color. Now, this is a puzzle targeted more at, I guess, our primary and maybe secondary school kids. But what I found when we started distributing this was even adults needed to use this puzzle, because you'll be surprised as to how many adults don't even know much about the countries we live in. So if we go to someone and say, okay, this is a map of Nigeria, where on this map is Lagos, not a lot of people will be able to tell us, or where on this map is Abuja, or where on this map is Kano. You're surprised that not a lot of people will be able to respond to that. Or even something like, okay, what are the countries surrounding Nigeria? Or on the map of Africa, where can you point out where Nigeria is? Or what country borders Nigeria on the east, west, So what this puzzle actually allows, why I really like it, is it not only it informs the student or the kid the positions of these countries or states, but it also allows them to understand the relative distance between the different countries or between the different states. So the distance between, say, Lagos and Enugu, for example. So and the relative size between Lagos and, say, Taraba State, or the relative size between Nigeria and Kenya. So all that, you'll be able to gain all that understanding without much effort. So it's not like you're reading a textbook. You're learning as you're playing. You're learning as you're solving puzzles. And I mean, this is just an example of making puzzles using additive manufacturing. Now the second image, the one in the middle, so I guess this is for like medical school. So this is a 3D print of the human anatomy. So again, instead of just going through textbooks and trying to learn, okay, where's the liver, where's this, where's that, you can 3D print the whole thing, and the students learning anatomy can literally be placing things where they are, and by doing so they are also learning as they're going along. Okay, this is where the diaphragm is in relation to the kidney, all those kind of details. So now we don't need to rely on pictures and textbooks anymore. You can actually have a first-hand feel of these things, and that's a much more effective way of learning. Now the third image in silver, um, so this is actually from a company. Now the image on the left is a schematic of a pneumatic valve. So previously the company will print this out for new recruits and say, okay, this is how a pneumatic valve works, and teach them that way just by in a textbook or a printout. This is how a pneumatic valve works. But what we did was we took that image, we created a 3D model from it, and then 3D printed it. So now instead of going by images, they can actually have it in their hand, feel it, play around with it, and see and get first-hand experience of how the pneumatic valve actually works. How does it shut down flow, in this case oil, um, and all of that. So again, a very effective way of learning, and that's how it's being used in the educational industry. So I guess with all of this, we can kind of see how additive manufacturing is very different from all other forms of manufacturing, in that you can really bring your ideas to life in a very short time. Where things would take weeks to make, you can literally think of something and have that thing physically in your hand within a few days, if not the same day. So at this point, I think I've been talking for a long
Yes.
time. I will
Thank you
I'll
so
open the
much.
floor for questions.
Yes, the questions have been pouring in already. Thank you so much for such an amazing presentation. I think I've got that covered. Yes. So is from the first question is from Alexander, and he's asking he's asking me actually, what can be done in Nigeria to have more construction projects, make use of 3D printing technology, and more organic building forms? Um, that's a huge question. Um, I would imagine the first thing would be things like this, educating people that it's actually even possible to use 3D printing technology, because as much as most people in the industry or even within the industry is still kind of becoming more mainstream more recently all over the world, not just in Nigeria. Um, the people who would commission you to build, for example, are clients. So I guess if more clients know about 3D printing and it's something they probably want to use to showcase how in touch they are with technology and so on, then it can become more mainstream. Or if it becomes cheaper, because at the moment it's faster but not necessarily cheaper, simply because labor in Nigeria is quite cheap. I imagine in maybe some other places where labor isn't as cheap, 3D printing would be the cheaper way to go. But at the moment, our labor is quite cheap, so it's still not the cheapest option. But in terms of speed and your ability to duplicate the same thing over and over again with precision, you can't beat 3D printing.
Okay. So
Um,
can I just also add?
yes, please.
So one of the biggest, I guess, barriers for 3D printing, especially in construction, is, as you mentioned, cost. Now, at the moment, the what is being manufactured are fast combs and I quote unquote affordable homes. homes or low cost homes. In Nigeria, that would then start competing with container homes, container housing.
Exactly.
And right now, container housing can still be gotten for so much cheaper than, I guess, a 3D printed home. So until the cost of, I guess, construction level 3D printing comes down, then I guess container housing will always have the edge in terms of low cost housing.
Yes, but just that's not to say that basically 3D printing is not the best because it's expensive. Because of the first of all, it's not done by human labor, which means you can now explore building in places where it might be difficult to maybe host a whole team of construction workers to keep working there. You can actually just set your machines there and have one or two people managing it remotely. It's now even possible that instead of relying on the expertise of local craftsmen, because that's one of the biggest challenges I think all Nigerians have, where the people here may not be able to execute the standard design for a very complex building. If it's a 3D printed building, you don't have that problem. So you can replicate your design anywhere in the world and it's the same thing. So it's to know its place, I guess. It's not necessarily going to completely replace how we are currently building. So the next question is from Adrija. Please forgive me if I didn't pronounce that correctly. And they're asking, can you tell me how the 3D printed fabrics are created and what material is used for it most? That is 3D printing eco-friendly. Okay, I'll give that a shot before I hand over to you, Akin. So is 3D printing eco-friendly? At the moment, um, research has shown that it is the same with what we're doing currently. So the advantage of 3D printing is that you're not going to be transporting maybe construction materials from one country to the other or having large trucks on our roads transporting materials and using carbon emissions. But 3D printers use a lot of energy to function. Basically, you're going to be leaving a 3D printer on maybe for 48 hours straight. So at the moment, 3D printers um, they consume as much power as maybe the carbon emissions we get from trucks. So the technology is still being developed to the point where it becomes obviously more eco-friendly than other methods of manufacturing. So the question about fabrics, I don't know if you want to take that, Akin, because I don't know much about
Okay.
3D printing fabrics.
Okay. So I guess I'll address both questions as well. Now, in terms of eco-friendliness, for construction, it's about the same. But for I guess low volume production, which I guess rapid manufacturing side of things, is actually a lot more eco-friendly. So some of the materials that is being used, some of the 3D printable materials are actually bioactive materials or biodegradable materials. So I guess that is, a bit biosafe. And also, just for the mere fact that it is additive manufacturing, you're only putting material where material is needed. So your wastage is a lot less. So we're talking up to about, say, 90% less material than, say, a comparable manufacturing process like subtractive manufacturing, for example, or forming. So for like forming, which is injection molding, there's a whole lot of wastage there. Even though we don't say it, there's a lot of wastage. And also for subtractive manufacturing, where you start from a block and then you chisel down to your final product, there's also a lot of wastage there. But for additive manufacturing, you're only putting material where the material is needed. So all the material being used is going to form your final product, right? So in this case, you're using a lot less material. Then for fabric, so the example I gave of the 3D printed, I guess, material, it's something called chainmail. So I guess that's what you can call the fabric. It's not really fabric because it's still made out of plastic, but it's loosely connected plastic that can take that flows, I guess, that flows the same way fabric does. So if you think of I guess back in where you have knights and they'll put on like an armor of a chain link armor. So it's something like that, but in this case it's plastic and you're 3D printing it. So then you can 3D print it into any shape that you want. Maybe it could be a t-shirt, it could be a belt, it could be a tie, but that's the concept around that. So I hope that that kind of answers your question.
Yeah. So we only have about 3 minutes left. So what I'm going to
Okay.
do is I'm going to summarize. Thank you all for attending. Please follow us online. Our handles are on the screen. I hope you can see them. I will also leave it in the chat box. But I will be taking all the questions that have been posted on the chat. So feel free to stay on if you would like to hear the answers to the questions. Otherwise, we are done with the presentation for today. So you can um, you could possibly log off at this point. So the one of the questions was about some sustainable materials for 3D printing. So I've seen people print a lot with earth. In fact, the university which I mentioned was is fully not was it's fully dedicated. It's a program that's fully dedicated to earth 3D printing, and that's where I also see potential for Nigeria and Africa as a whole, because those are some kind of materials that we have in excess. So they are researching how currently with concrete 3D printed homes, they are all self-supporting, so they don't need a lot of structural support per se. They've been designed to hold, like the building is designed to hold its own weight. So a lot of research is going into printing earth buildings that can hold their own weight as well, so that the earth doesn't crumble in on itself. There's also been strides in 3D printing glass. I saw a demo with maybe some of you might know Professor Neri Oxman at MIT. Her own lab has done a glass 3D print. And the printer, so the thing about 3D printing, which I guess we didn't really talk about, is that your material is solid, and then the printer gets really hot and melts it into a liquid state for it to be able to basically mold it into whatever object you're trying to print. So for glass, which in its liquid state is really hot, the 3D printer they used was about 1,000 degrees Celsius or 1,900 degrees Fahrenheit in heat to be able to melt the material and print out glass. So those are some of the things that need to be sort of tweaked, or basically it's hard to have a small scale 3D printer that can print glass at 1,000 degrees Celsius, so to speak. You need a whole room for that. Someone is asking, how and where do you sort the filament? So the most commonly used filaments are called PLA. There are other filaments, but the most common one is PLA, and you can get it on any online platform: Jumia, eBay, Amazon. Akin sells them. If you want, you can patronize him as well. So Akin, someone is asking you, what are the challenges you have faced within the industry in
Okay.
Nigeria?
Okay. So some of the challenges, I guess one major challenge is cost. So now, if you if you remember, I said for 3D printing, we need to start from the 3D model. Now, imagine someone comes in and wants to say replace the handle of their washing machine, for example. Or actually, no, let's not use that. Let's say the cover of a bottle, the cover of their water bottle flask. Maybe it's broken, and they don't want to have to buy a new water bottle. So now to 3D print that, the first step is to do the 3D model. Now, if that person doesn't know how to 3D model, they'll have to pay someone to do that. And to pay someone to do the 3D model for them, it's already gone past the cost of a whole new water bottle in the first place. We've never even talked about the actual 3D print. Now, the actual 3D print may be cheaper than buying a new water bottle, but just the design process, because you have to pay for someone's time to create a 3D model. And I mean, depending on what that person is going to charge, which could be as much as like 50 to 100,000 naira, it may not be worth it anymore. So um, I guess that is something that could be seen as a challenge. Um, so another challenge is just is more like a mindset thing. So because we are making plastics, the common conception is that it's going to be cheap, and the reason for that misconception is because because our previous manufacturing method, which is forming, so forming makes very cheap plastic products. So that's why we can go out now and buy a cup for less than 100 naira, because it was manufactured using the forming technique where you get a mold, and then using that same mold, you're injecting um, plastic into the mold and making like thousands of cups every day. Now, this is not possible with 3D printing because one, it's a layer by layer technique. So it's impossible to get, so a cup that's going to cost, say, 100 naira to mass produce will probably cost about 5,000 naira to 3D print. So that's a misconception, but I would say that for if you're looking for something, the first thing you should ask yourself is, can I get this thing from the open market? If the answer is yes, then typically there's no reason to actually 3D print that thing. If the answer is no, then yes, it's going to be worth it to actually pay for the design, pay for the 3D model if you can do it yourself, and pay for the actual 3D print, regardless of, I mean, cost then becomes less of a factor. So I hope that sort of addresses the question. So those are the two main challenges. I guess I'm seeing a question about where we source filament from. So we have partnered with a factory, not in this country, but abroad, that supplies us filaments. So we bring in boxes of filament, which we supply. And eventually, once the market matures enough in this part of the world, we will start actually making our own filaments as well. So that is so that's something to watch out for. But the raw material is readily available.
Okay.
Okay.
So
Let's see
someone
another
is
question.
asking, what 3D printer would you recommend for a starter or novice? Because 3D printers can be quite expensive. That's from Kabir.
Okay. So now there actually you can get a 3D printer for as low as, I guess, $200, 200 US dollars, which is about 100 to 150,000 naira. Uh, Now that is a beginner printer, but then with that you have to be a little bit technical minded. Um, the printers we use here are a bit more robust and a bit more, I guess, industrial, and those ones will set you back about 1 to 1 million to 2 million naira. But those are for if you'll be doing, if you like to use a lot more materials, be doing a lot more complex and complicated parts, and a lot longer prints as well. So those printers can probably print non-stop for 72 hours to 1 week, non-stop just printing. And if you think of all the heat involved, for some materials, you're gonna need to heat up the printer to as high as 300 degrees centigrade. So I guess a lot of these lower cost printers may not be able to handle that. But if you're just starting out, then you could use a simple material like PLA, which is a biodegradable material, is readily available, and it doesn't really need that high temperatures. So you could use that to start out to, to get your fingers dirty and, you know, play around with the whole process. So about $150 will get you a beginner printer. You may need to do a bit more research, and it's a bit more technical to get going, but it's a way to start.
Yes, and bear in mind that the size of your print is affected by the print bed available on whatever printer you're buying. Is one of the specifications you always see on a 3D printer is the size of the print bed. And usually a print never even gets as big as the entire print bed because for its own safety, it gives like a kind of perimeter around whatever object you're printing. So if you're trying to experiment with just small scale objects, which to be very honest, I think the cheaper printers would only be able to give you smaller prints, which is good for a start because the process is the same. I think someone else asked about scalability. It's very scalable. The good thing about the small sizes is once you're able to prototype it and your settings and the outputs are satisfactory, um, maybe with a little more tweaking, probably not, but you'll be able to do the same thing on a large scale, really even human size printer, and you get the same results. So the last
Okay.
question, sorry,
So
I'll let you speak on
okay.
that. Yes, I know, I'm sure you have more advice for that person. But the last question is for someone who is asking how best 3D printing could impact Nigeria and help with Nigeria's development. Personally, I would say 3D printing. And please, I think this question goes out to all the Nigerians on this chat. You can help us by putting your answer in the message box. How do you feel 3D printing can impact Nigeria's development? Personally, I would say in terms of affordable housing projects, I believe on that scale where you're building for so many people and trying to cut down on cost with the fact that um with the fact that 3D printed buildings now, the kind of research going into them is for them to be self-supporting. So you're not going to need to hire a lot of people to be on site for years and years. You're not going to have to do it. Like you basically just have to find land, which the government probably has, and import a few printers. The material is available. You just have to train some people to know the right mix and then just monitor the printers. So I think at that scale of development where you're building several houses for people who can't really afford like regular standard homes, I believe that would be a good way to improve Nigeria's construction with 3D printing. But that's just my opinion. So if anyone else has anything to say. So over to you.
Okay. Um, so any other new questions, or should we start running up?
Yeah, no, you were going to say something about the 3D printer to buy.
Okay, the 3D printers to buy. I think I may have already talked on that. So they are okay, in terms of build volume. Okay, yeah, you mentioned build volume. Now, again, it's digital manufacturing, right? So you can, even if you have a printer with a smaller build volume, you can optimize your designs for that build volume, and then design in such a way that your product is modular. So you print in different parts, and then once you have all the printed parts, you then assemble it together. So if your design is a full scale human, then you know, okay, I'm going to do the foot, then I'm going to do the ankle, then I'm going to do and then just keep on building like that. So it will take you a lot longer than using a bigger printer, but at least it all depends on your design. So with your design, you'd have taken into consideration that you'll be printing separately and then assembling afterwards. So that
Yes.
was just what I wanted to say.
Okay. So yeah, you guys have really hung in. Thank you so much for staying this long. We are still taking questions, even though like you're free to leave if you're tired, but if you just want to hang around for the discussion, that's fine. Um, so Alexandra is asking, what are the limits of 3D printing building construction? From what I know at the moment, one of the limits is with the form. So, like I said, the whole point of 3D printing is to have self-supporting structures. And um, one of the reasons that is, it's not as if you can't really support 3D printed buildings. In many cases, they are supported at specific angles with like maybe steel rods in terms of concrete buildings, or timber with um, earth buildings, just because timber is more sustainable. So one of the constraints at the moment, I would say one is height. So you can't really go too high for something that is self-supporting. And considering that land is a finite resource, I doubt um like we can carry on just building standalone short structures all over the place. After a while, we'd have to figure out how to make 3D printed structures a little higher, which people are already working on. So it's not like it's impossible. It's just time, research, and money has to go into it to be perfected. Then another thing is, because it's self-supporting, you can't really have a straight wall in the way you would have a block wall that's just rectilinear and straight and just going on and on. Most 3D printed buildings have curves in it, and I think I could probably show you in the slide that I showed before. That's because if it's straight, especially with a material like earth, after a while it starts to crack at joints. And because you're going layer by layer, there's so many weak points where the material can actually just start cracking if you're not careful. So I'd say that's one of the main weaknesses with that method. So you can see most of the walls, they just can't be like straight, like a regular block wall. It just wouldn't work for a 3D printed building. For more questions, you can follow us on our social media handles. We can talk more about this if you have even more questions, which I'm sure you have. Thank you so much. Thank you all for attending. Okay, just before we go, our managing director has given us a suggestion for starting out to improve housing in Africa. So we can explore the design of components to improve on what we currently do, which is very true. It's crazy that many of these self-supporting structures, which I mentioned, are something that our traditional architectural settlements have in abundance. I believe that with 3D printing, we can go back and study those practices and make it more resilient. And we can definitely build components that work for us. The way someone has thought about 3D printing a wall that has its own insulation, we have different problems here, especially in Lagos, which is a coastal city. So I think we can really um, go back and look at how our buildings can work for us since we now control the manufacturing aspect of it. Um, Thank you so much for attending. So I will end it now. Thank you so much. Please send all your questions to my email and have a good weekend. All right. Bye.